Hi, this is Jason Toledo, and this is my final project for cs677 Data Science with Python. What you see on the screen is the zip file I've submitted. So to actually run the file, there's a README document I created which has the instructions, but you simply need three files: the NBA players.csv file, the NBA rookies.csv file, and the zeta046 final project.py file. I've included a Jupyter Notebook IPYNB file, which includes my EDA, which we'll take a look at right now. The data set that I selected is the NBA players data set. This contains about 1,293 players. That contains their statistics for their rookie season. The target variable is target_5 years, which I'll be using in my models. This indicates if this player has actually played in the NBA greater than 5 years, and lists their statistics for the rookie season. Here I've dropped the duplicates, which there aren't any. I have described the data, gone through the correlation analysis, and I've also printed out the heat map for that, which appears in the .py file. The first model that I went through was logistic regression. I scaled the data, split into test and training data sets, and you can see the accuracy is decent. It's at 72.2%. I have the confusion matrix printed out, which rolls up into a final summary table at the end, and also the root mean squared error metric, as well as the feature importance scores. What I realized going through this is that there are some redundant columns of data. So field goal, for instance, is simply the field goals made divided by the field goal attempts, FGM and FGA. Decided to remove that. Rebounds was the combined offensive rebounds and defensive rebound totals. Free throws was the same as the field goal attempts, and then we have 3P, which was the percentage of three-point shots made. So this actually improved the correlations a little bit. They're all positive now. I decided to rerun it through logistic regression again. I played around with the solver and the penalty values. The score was a little bit better in terms of training, but not the accuracy was actually the same. I go through the same type of analysis with the correlations. The next model I go through is random forest, which I try 30 values for N and 10 values for D. This takes a little bit of time to run. Just FYI, found that the best combo is 9-1, and we'll go through that. Similar structure. The next model I used was XGBoost, which we did not cover in class. I used this with 100 estimators and tried to get the best score possible. Played with the learning rate and gamma values. It was very close to logistic regression, but not quite there. And finally, I used naive Bayes, which ended up having the worst score of all four models. We could see here the summary table and RMSE tables. Highest accuracy was logistic regression. And what's interesting is I've taken a rookie's CSV file, which contains all the 2021-2022 rookies and their statistics. This file contains 100 rookies. This goes through the best and worst performing models and does predictions based on those, and they varied in their results, and it outputs a final file with two different columns with the results. And I will execute that now in VS Code. And this will print out the summary metrics. We have the heat map here, and we'll let that continue. We have the importance bar chart that populates. Now this is on the random forest, so it's taking a little bit of time. It takes about maybe 10 to 15 seconds because we're running so many iterations, trying to get a very solid model. And here at the end, we'll see that the updated rookies CSV file has been created. And that is my project. Hope you've enjoyed this video. Thank you so much for your time.